Welcome protein coders, let's build some coding muscles. Today we're gonna see a topic, cycle detection in undirected graphs. Okay, in undirected graphs we can detect cycle using DFS, BFS and disjoint set union. We will see the DSU part later on when we study, but now let's focus on DFS. Okay, so in DFS here is our graph and adjacency list and visited array. Let's start traversing from the node number 0. Okay, we'll mark it as 1 in visited array and we'll move to its neighbor, which is 1. Okay, then we'll mark 1 as visited and we can move 1 has 3 neighbors, right? 0, 5 and 2. 0 is already visited, we can move either to 2 and 5. Let's move to 2. We'll mark 2 as visited and similar fashion we'll move to 3, then 4, then to 5. At 5 we have, if you see in adjacency list, we have two neighbors, 1 and 4, right? 1 is also visited and 4 is also visited, right? Both are visited neighbors. Now how are we going to detect the cycle? If you see carefully, 4 is the parent from where we have arrived to 5, right? And 1 is not parent. So from here we can have an observation. We can only say we found a cycle if a neighboring node is visited, right? And as well as it should not be parent. If it's a parent, then it's not a cycle. If it is not a parent, then only we can say it's a cycle. Okay, so yeah, this how simple it is. Let's look at the code of the DFS. How we're going to use DFS to detect cycle. Okay, here in the DFS we have an extra parameter. You can see it's parent. Okay, so let's perform our DFS. We will first mark our node visited, then we will traverse for the neighboring nodes, okay, using adjacency list, and we'll check if the neighbor is not visited. If it's not visited, we can simply call DFS for it. Okay, but else if it is visited, then we have two conditions. Remember, it can be a parent or it can not be a parent. So we'll check else if neighboring node is not parent. Okay, so as we discussed, if it's not parent, then we found a cycle. Voila, so we'll return true. And after all this, if we didn't found any cycle, we will just return false. Okay, so that's it. One optimization here, like while calling for DFS, we will check if any of our DFS call returns true, then we will return true. No need to go further and do extra DFS calls. Okay, so it's just a small optimization here. Now let's see how we're gonna do using BFS. Let's start from 0 again, mark it as visited, then we will go to its neighbor 1, mark it as visited, then the neighbor of 1s, which are 5 and 2, right? Then we will pop 5, we will insert 4 in the queue, we will pop 2 and insert 3 in the queue. Now here we will pop 4 and see 4 has two neighbors. In the adjacency list you can see 3 and 5. Okay, but 5 is the parent. Okay, so to get the cycle, we again have the similar condition as DFS. The node should be visited and it should not be parent. See in the graph again, 4 has two neighbors, 5 and 3. 5 is the parent, so we'll not take it as cycle. 3 satisfies the condition. Okay, now let's see the code. In code, how we're gonna do it. Okay, so again we will perform our simple BFS. So first, what we're gonna do, we're gonna have a queue data structure, but in queue we will store a pair of integers. Okay, why? The first part will be the node and the second part will be to store the parent of the node. Okay, Now our simple BFS, we will mark the visited of this node or starting node as 1. Then what we're going to do, we'll push it into our queue. Okay. Initially our parent of the starting node is -1. Okay. Because there is no parent. Now we will just start our while loop till queue is not empty. Here we will just pick out the node and the parent from the queue. Okay. And then we will pop the node. Small correction here, it should be queue.front.first and second. Okay. Then we're gonna traverse it. Okay, for the neighboring nodes. So again, similar thing, if it's not visited, we will simply call a BFS, right? We will mark it as visited and we will push it into the queue. Else, if it's not visited, then what we're gonna check, if it's not parent, the neighbor should not be parent. If it's not parent, we will return true. And after all this BFS, if we didn't found any cycle, we will just return false. Okay, so this is it. Let's see once again. First, we are inserting a pair of integers for node and parent. Okay, then we are pushing -1 at the start. Okay, starting node doesn't have any parent. Then we are traversing. Okay, we are getting node and parent. Then for every node, we are traversing for its neighbors. If the neighbor is not visited, we'll just push it into the queue. Okay, and here the parent node will be the node. Okay, else if neighbor is not parent, then voila, we found a cycle. We will return true. Okay, now a note, we can have multiple components in our graph. So how to tackle it? We studied it, right? In earlier videos, we will just run a for loop for each node, and for each node we will check if it's not visited, then we will call BFS, right? And here our BFS and DFS are returning values, Boolean values. So we will check if DFS is returned true or not, or if BFS returned true or not. If they are returning true, we will return true, or else we will return false. So that's it, guys. Let's recap what we studied today. Cycle detection and undirected graph. 3 methods are there: DFS, BFS, and DSU. DSU will be for later. Okay, we saw in DFS that what is the criteria? The neighboring node should be visited and it should not be parent. If we found a condition like this in any neighboring node during traversal, then we got a cycle and we will return from there, return true. Then similar thing in the code, and we did a small optimization also here. Like in any call, DFS call, if we found a cycle, we will return true. Okay. Then we saw in BFS also very same criteria for the node while traversal. If a neighboring node has a neighbor which is not parent, then we will call it a cycle. Okay. Now in the BFS also we saw we took node and parent, right? A pair, we pushed it into the queue. Then we did the traversal, and in traversal also similar thing. While pushing, we pushed neighbor node, comma node. Here the node is the parent of the neighboring node. Okay, from where it is coming. Or else if the neighbor is not parent and is also visited, then we are returning true. We got a cycle. At the end, if it doesn't found any cycle, we will return false. Then we saw a very important note: graph can have multiple components, so it's preferred to have a for loop for every node. If it's not visited, then call DFS or BFS. Okay guys, so that's it. That's all from my side. You can find problem and solutions in the description. If you have any question, please comment down. If you don't understand, don't like, don't subscribe. But if you do, please support. Keep smiling, keep practicing. Thank you.